ammonia. So OH from this and H from this, there is a removal of water, and this NH2 negative will attack on the carbonyl carbon, and you get such type of amide compound, right? So here we have seen, okay, okay, just wait, I will check my, so just wait, there was a loss of power, so that's why again I have to share my screen. Now I think you can see my screen, okay, right? Can you see my screen?
Yes, sir.
Yes, sir.
Now you have to tell me that you couldn't see the screen. No problem, no problem. Okay. Now I think now you can see, right? So here just what you have learned, we have learned that amides when treated with acid halides, when treated with ammonia, there is a formation of amide, or acid anhydride react with ammonia, there is a formation of amide. Okay. And we are learning about the chemical properties. In the chemical properties, here the amide when undergo hydrolysis in the presence of acid, there is a formation of carbonic acid with removal of ammonia. And amide when undergo hydrolysis in the presence of alkali, also there is a formation of acid which will convert into sodium carboxylate in the presence of alkali with removal of ammonia. And next reaction is the amide when undergo, that is the reaction with alkali NaOH and Br2 bromine, it undergo Hofmann degradation reaction. So there is a decrease in the number of the carbon atom. It is also called as a step down reaction. So amide to amine takes place. Here there were the two carbon, but here there is only one carbon. So it is a step down reaction. It is called as a step down reaction. Now here example, if R is CH3, it is called as acetamide. Acetamide will convert into methylamine, and benzamide will convert into corresponding aniline. So these are some of the chemical reactions given by this amide. Okay, so this was the one of the functional group that we have to learn. Okay, then there are the two name reaction. We'll learn that two name reaction. One is your Reed-Hormozky reaction. Reed-Hormozky reaction. Reed-Hormozky reaction. Reed-Hormozky reaction just similar to your Grignard reagent. So what happen when carbonyl compound CH3, C double bond O and CH3, carbonyl compound aldehydes and ketone, when treated with alpha haloester, when treated with alpha haloester, here is a CH2, C double bond O and C2H5. So it is your alpha haloester, alpha haloester. The reaction takes place in the presence of zinc. Then number one, and second, it undergo hydrolysis in the presence of acid. So it is seen that there is the formation of, that is the beta, here is a CH3, then COH, here is a CH3, here is a CH2, C double bond O and O, C2H5, alpha carbon and beta carbon, beta hydroxy ketone. So there is formation of beta hydroxy ester compound, right? Let us see the mechanism of the reaction. Very simple mechanism. Here what happen, the alpha haloester react with zinc just like RMGX Grignard reagent. There is a formation of alkyl zinc bromide. So here you get such type of complex Zn, CH2, C double bond O and C2H5, right? Now what happen, the zinc is having the positive charge, that's why the CH2 is having the negative charge. So CH2 negative and Zn positive. pi bond open on the oxygen O negative and C positive. So this CS2 negative will attack on the C positive, and there is a formation of, so number one, CH3 C double bond O and CH3 react with Br Zn CS2 C double bond O and C2H5, right? Reaction takes place in the presence of ether. Pi bond open on the oxygen O negative C positive. So this C negative will attack on this C positive, and Zn positive will attack on this O negative, and there is a formation of CS3. Here is a CH3, here is O, then there is Zn and here is your CS2 C double bond O C2H5, right? Now next one, in the next case what happen, it undergo hydrolysis, right? It undergo hydrolysis, addition of water in the presence of acid. Here it undergo breaking, O negative H positive Zn positive OH negative, and there is the formation of final product that is a CH3. Here is OH, here is the CH2 C double bond O and OC2H5. So alpha carbon and beta carbon. So beta hydroxy ester. There is a formation of beta hydroxy ester. Right. So the required thing is that there must be presence of at least alpha hydrogen atom, one alpha hydrogen atom. So it is called as, that is a Revformsky reaction. Right. Last reaction from this topic. So Perkin reaction, Perkin condensation or Perkin reaction. In Perkin reaction, what happen? The starting compound is a benzaldehyde. Here is a benzaldehyde. Here is a pi bond, pi bond, pi bond. Here is a C double bond O and H. It reacts with acetic anhydride. It reacts with acetic anhydride. So this compound, it reacts with acetic anhydride, right? Yes. So here is a CH3 C double bond O. Here is O. Here is a C double bond O and CH3. Reaction takes place in the presence of sodium salt of carboxylic acid. Corresponding carboxylic acid means sodium acetate. So there is a formation of pH for benzene, CH double bond CH and COOH, means there is a formation of cinnamic acid. So in this case, there is a formation of cinnamic acid takes place. Now, what is the mechanism of the reaction? In mechanism, what happen? Here, there is a reaction with the base. Base is sodium acetate. There is a reaction with the base. Base is sodium acetate. One of the hydrogen from the CH3, this is shift here, C becomes negative, and there is a formation of a carbanion. So C double bond O, here is O, C double bond O and CH3. Further, the pi bond open on the oxygen on the carbonyl carbon of benzaldehyde O negative C positive, and the C negative will attack on this C positive, and there is a formation of, here is the benzene nucleus, pi bond, pi bond, pi bond, here open on the oxygen, here is the H, and the carbanion will attack on the carbonyl carbon. So you get such type of alkoxide, and further this alkoxide, it undergo protonation, and you are getting corresponding OH group. Here is a benzene nucleus, here is a CH, then OH, here is a CH, then C double bond O, here is O, C double bond O and CH3, right? And further, it undergo hydrolysis, addition of water in the presence of acid. So what happen? This will attack here, addition of H, addition of OH, and you can get benzene nucleus, then CH, OH, then CH, OH and COOH. Here is the H, right? Here is the H. And further, when you hit it, right? Further, when you hit it, what happen? It undergo dehydration reaction. So this sigma bond open on the OH negative, C positive. So this sigma bond will shift here formation of double bond. So it is your pH, CH double bond, CH and COOH is called as cinnamic acid. So in this way, there's a formation of cinnamic acid takes place, right? So this is one of the name reaction, Rip-Hormozky reaction, and second is the Perkin reaction, right? So in this way, we have completed this the chemistry of carboxylic acid and its derivative. So if you have any doubt, you may ask. In this one, if you have any doubt, you may ask. Any question? Yes. Any question? No. Okay, then tomorrow again by 10 o'clock we'll start our lecture. Now it's 1:55, 5 minutes are there. So again tomorrow by 10 o'clock from 10 to 11 we'll take your lecture, right? And we'll start last topic, that is the amine and diazonium salt, right? So continuously we'll take a lecture at 10 o'clock till your syllabus complete. So if you take 2 hours tomorrow and day after tomorrow, we will complete this topic also. Okay. And then we'll go for the revision one by one with objective type questions. Okay, sir. Okay. Then thanks to all, and you can leave the meeting. Thank you.